Okay, so start by introducing it. So we are both mainly web programmers, do like a lot of web programming. So as a hack this time, we decided to do something a little bit more abstract. Maybe not specifically relating to a final product at the end, but kind of like a challenge to see how well we can implement something that is fairly complex. So basically, here, I'll just open it up and you can see initially. So this is 3D rendering of it's actually a castle. I think it's in Italy or Spain called Sponza. That's just why our team name is called Sponza, which is the explanation. But so there's a lot of things that go into making like a game look really good, right? So this obviously everything looks really flat. That thing in the middle is just white. Like it looks kind of okay because the textures are reasonably good, but overall it just looks like a really 2D environment. So there are a lot of techniques that can go into improving this. So I'll show you can like move around here. So the first thing is obviously going to be like lighting, right? You want to kind of add some depth to the scene. So either you have two choices. One, you basically you have a whole bunch of lights all around your scene, and you want to compute the lighting at each point. So you can either, for all of your geometry in the scene, compute the lighting there, and then project that onto the screen, and then you have your final lighting. Or you can use a relatively recent technique called deferred shading, where you render to what's called the G buffer a whole bunch of information. So like top left is just like the color, bottom left is the normal, so like a surface vector pointing away from the surface. Bottom right is specular color, so that's like how shiny the surface is, and then the top right is depth. And the cool thing about depth is that using the inverse transformation matrices, you can actually go back from the depth to the position in the actual world, and do all of your lighting in what's called screen space. So instead of having to light every single bit of geometry in the world, you light the pixels on the screen, which is a lot cheaper, and you can have like orders of magnitudes more lights, so like thousands, that kind of thing. So we decided to try implementing like a lighting model based on this in like the 20 hours. We haven't done like OpenGL stuff in quite a long time, so it was a fun challenge. So I'll show you the basic lighting model we have here. So I'll just move the lights over on top there. So you can see how on the dragon there's some what's called diffuse light, which is just like the color, and then some specular, which is like the shininess. And that's just a giant light up there, which is the sun moving around. This is a day and night model. So that's like pretty cool. It's a good step in the right direction, right? And then one thing that's missing though is like all the little bits of like darkness around the edges that you get. So for example, if you look at like those gray things on the wall, around the edges and at the bottom, you still have some kind of like ambient term where the light can't reflect because of the edges. So I'll just move the sun back a bit. It's like left and right. So there's a way to do this also in screen space called ambient occlusion, or screen space ambient occlusion. So we implemented that, and you end up with something that looks kind of like this, which is pretty neat. Things seem to have like some depth to them, whereas they didn't before. So if we look at this, this is like actually rendered like really, really cheap, which is pretty cool, and it like looks pretty good. Yeah, 30 seconds. So yeah, that's like the basic lighting model there, and it's pretty cool because all of this is dynamic. So if we go up here, like there's a light over there, and everything actually casts shadows. So if you saw as the sun is coming down, so we have like a day-night cycle kind of thing. So the sun comes down, it's casting a shadow there, going back the other way. but everything, like if you look under here, there's actually shadows being cast through there. It's not perfect because we had a limited amount of time, but yeah. It was a fun project to do with a limited amount of time. You know, that was basically it.